Let's have a look at this probability question. We've been told that a factory uses two machines to produce screws. 4.8% of screws are faulty. Machine A produces 70% of the screws and only 3% of these are faulty. Find the probability that machine B produces a faulty screw. There's a lot of information here, so we're going to use a tree diagram to help us understand this question. So if we just move the question out of the way. So first of all, we know that there are two machines that are used. It's produced by A or machine B. The options on any tree diagram must be mutually exclusive. It cannot be produced by machine A and machine B, and the probabilities from the branches must add up to 1. So as we know, the probability it's produced by machine A is 0.7. The probability it's produced by machine B must be 0.3. Okay, we're working in decimals just because it tends to be a bit easier. After that, we have the next thing that can happen. Either a screw is faulty or it's not faulty. Again, mutually exclusive, it can't be both. So once it's been produced by machine A, the question told us that there was a 3% chance that it would be faulty. That must mean that there's a 97% chance that it's absolutely fine. What we don't know yet is the probability that if it's produced by machine B, it's faulty. But there's enough information in this question for us to figure that out. Okay, once we've got the tree diagram drawn, it's always a good idea to start putting some numbers at the very ends of these branches. So for example, if I know that it's produced by machine A and faulty, if I multiply these numbers together, I'll get the probability that it's A and faulty. So this here will be probability A and F. Looking at that, 0.7 times 0.3 is 0.021. Similarly, we can do this branch here. Two ways to calculate this now. I can either do 0.7 times 0.97, or if, for example, I've been given different information in the question, I know that these two numbers must add up to my 0.7. So just in terms of doing the mental arithmetic here, that's slightly easier in this case, 0.79. But I would get the same answer if I did that times that. So the question has asked me for this number here. That's what I want to know. The probability that a screw produced by B is faulty. So if we just look at the question again, they told me that the total probability of a faulty screw is 4.8%. That must mean that my two faulty ways, A and faulty, B and faulty, they must add up to 0.048. Okay, so it's A and faulty plus the probability of B and faulty equals 0.048. And I know that this is 0.21. Doing that calculation, I can see that the probability of B and F produced by B and faulty is, I just spot a little error there, is going to be 0.027. So that's told me that this here, probability of B and faulty, is 0.027. I know I would get that number by doing 0.3 times this equals that. I can work that backwards. I know that this number here must be 0.027 divided by 0.03. Put that in the calculator and it tells me that it is 0.09. A 9% chance of it being produced by B and then being faulty. Whilst I'm here, I might as well complete my tree diagram because in the exam there'll probably be a part B or C to this question. So I know that that's going to be 91% chance that it's fine. And then multiplying along here, the probability of B and F will be 0. Why can't I do the maths all of a sudden? Let's just type it in. 0.91 times 0.3. There we go. 273. So I know the probability of all of my different combinations of events. I can then use this tree diagram with the numbers at the end to figure out anything that I need. And that's how we can use a tree diagram for slightly more complex questions.